The moon is vanishing. Yes, you heard that right. One day, the moon will be far enough that it will not be orbiting the Earth anymore, and we have no control over it. It is inevitable. What is causing the moon to drift away from Earth? When is it going to leave us? And can we live in the absence of our closest and oldest cosmic neighbor? In today's video, we will unveil what we know about the moon and Earth's imminent separation. Everything we know about our oldest cosmic companion. The moon is like the Earth's best pal. It is the brightest object in our night sky, and it is fascinating to look at. But how much do we know about the moon? How did it become entangled with our planet? To understand this, we must journey back in time roughly 4.5 billion years ago, around the period of the Earth's formation. The Earth back then was, let's just say, not the sort of planet humans could live on. It was like a massive molten ball of unimaginably hot magma, entirely unlike the Earth we know today. After Earth's formation, its cosmic power arose in the most catastrophic fashion. Many scientists rely on the giant impact theory for the formation of the moon. According to the giant impact theory, the moon emerged when the Earth collided with a space object called Theia, a hypothetical ancient planet the size of Mars. And that's where the billions of years of relationship between the moon and the Earth began. Fresh out of the cosmic oven, the moon was smoking hot, just like the Earth when it was created. And it can still be pretty hot these days. As a matter of fact, the temperature of the moon can go up to 260 degrees Fahrenheit or 127 degrees Celsius when it is illuminated by the sun. When we first touched the lunar surface, it was indeed a massive leap for mankind. However, there may come a day when we will not be able to reach the moon. Why? Well, it is gradually moving away from the Earth. When will the moon leave Earth? And more importantly, what will happen if we lose our lunar companion? Before we explain that, we must understand how the connection between the Earth and the moon works. It is crucial to understand how the moon has stayed with the Earth for almost 4.5 billion years. In comparison to the larger planets, Earth is the only planet in our solar system with only one moon. Larger planets have many more moons. Our moon has remained a faithful companion for billions of years. Jupiter and Saturn, two of the biggest planets in the solar system, have a staggering amount of moons, 80 and 83 respectively. You may be wondering how these two titans manage to hold so many moons. It is mostly due to one fundamental component of the universe: gravity. The same holds for our Earth and the moon. The difference is just that Jupiter and Saturn are unimaginably big compared to our Earth. The greater the mass, the higher the gravitational attraction between two objects. Because of Jupiter and Saturn's enormous masses, their gravitational attraction became incredibly powerful, attracting countless rocky objects to orbit around them. Of course, it's not only the object's mass that brings two masses together. In the case of our Earth, which is far smaller than these gas giants, our gravitational attraction was only strong enough to attract a single moon, which accompanied us for a long time. You may be wondering why certain larger objects in the solar system, such as Jupiter or even the Sun, did not attract our moon instead. How did our little planet keep the moon orbiting it? When we evaluate Albert Einstein's field equation, or his formula for gravitational attraction, we must consider not only the mass, but also the distance between these two astronomical objects. It just so happens that our moon is close enough to the Earth for the gravitational attraction of the Earth to attract our lone lunar companion. But that might not be the case anymore one day, as the moon is slowly leaving our planet. Can you imagine not seeing the beautiful full moon in the sky each month anymore? Is there something we can do to avoid this ill fortune? Why is the moon moving away from the Earth? Remember earlier when we explained the giant impact theory for the origin of the moon? Earth collided with another planet called Theia. I forgot to tell you one crucial detail. As of today, the average distance of the moon from our Earth is 238,000 miles, or 383,000 kilometers. However, when the moon was blasted into space as a result of the impact, its initial distance to the Earth was just 15,000 miles, 24,000 kilometers, which is over 20 times closer. What's more interesting is that because the moon was so much closer to Earth, its gravitational pull caused our planet to spin faster, which caused a day on Earth to be between 4 and 6 hours instead of 24 hours. Now comes the nagging question: why is the moon moving away from the Earth? The first thing we need to understand is the main catalyst driving our moon away: the tidal force. Most of us are aware that the movement of ocean waves, such as high and low tides, is driven by the moon. These are the effects of tidal waves. So, what is tidal force? It is a gravitational force that causes a body to stretch along a line towards the center of mass of another body. It's somewhat similar to a rubber band. If you exert force to pull a rubber band, it stretches and elongates, while the top and bottom part of it becomes tighter. The Earth is also being pulled upon by the moon. Because the Earth is covered by a lot of water, when the moon provides its pulling force, it causes the water to be pulled to the side of the Earth facing the moon. This bulge of water represents what we call high tides, whereas the areas where it becomes a little tighter represent low tides. Naturally, this bulge should now point in the direction of the moon's center. The interesting part is the Earth is also spinning, and it is spinning way faster than the moon. The Earth's centrifugal force causes the bulge to move slightly ahead. Now, the bulge is not pointing towards the direction of the moon's center, but slightly ahead of it. It is like a giant tug-of-war between the moon and the Earth. As a result, more gravitational pull is drawn to the front of the moon, causing it to accelerate and follow the direction of the bulge. Because of this, the moon is moving away from the Earth every second. It is, however, moving away from us at a far slower rate than we can notice, with around 1.49 inches or 3.78 centimeters every year. Even at this modest pace, a day will come when the moon will no longer be our companion, as it will no longer be visible in the night sky. What happens if we do not have a moon? The first and most noticeable effect will be that our nights will become substantially darker. However, not only the evenings will change. The lack of the moon's gravitational resistance will cause the Earth to resolve significantly quicker, resulting in days lasting just 4 to 12 hours. One revolution of the Earth around the Sun completes a year. With shorter days, 1 year may take about 1,000 days long. The second effect is on our ocean tides. Scientists anticipate that without the moon's effect, the tides will fall to 1/3 of their current size, as the one that will remain are solar tides, tides that are affected by the sun. The final and most damaging consequence on Earth is the dramatic shifts in our planet's tilt. We will experience intense and severe seasons as a result of these changes, or there is a risk that there may be no seasons at all. Imagine all the things that will change in the absence of the moon. Next time you see the moon in the night sky, take a moment to enjoy its beauty.